So we will get the transfer function. So I would like to write the numerator, and then use the ORD2 to get this. As we understand just now, we have to start with the omega n, and then it's the zeta. So for that, you can try to run. Okay, you can try to run all this. So this is our equations that we get. We can see that it's the second order system because it's s power 0, s power 1, and s power 2. So s squared plus 19.97s plus 209.4 the characteristic equations. So we know that after that we need to get it in the third order system, because what we can compare if we do the calculation, right? So for here, then we will use this. We try to get the roots from our, because like what we see here is the already in the equations, right? Polynomial equation. So if I want to get the roots from it, I can try to use the roots command. So from where the roots, I want to get it from the then. Okay, so then if I run this, you will see that this is two roots that we have, right? So what we understand from our example solution, we know that we should add the third poles. For this case, we choose is the this is the poles, the name. So we choose is the 10, right, to cancel the 0 at -10. So then we can write here is R1 is the R2. No, okay, I have to write in this way. R is this. Okay, if you see here, you double click, you can see that this is the R. Okay, this is the R, the two value that we have. Okay, so I want to put in this, let them know the poles got 3 now. First one is the from the R first value, then second one, and now the third one is -10. Okay, so from here, if I try to run, so I will see that now my poles I have these 3 value, see? Okay, 3 value of the poles. Okay, so then now I know it's 3 value of the poles, then I can arrange them in the equation again. So my characteristic equation, I call it ds. So I use poly command to please arrange my poles. So later on you will see poly will give me polynomial equations, which is this one. Okay, here is the 1000, right? So 0.001, so actually it's a s power 3, and then 30s squared, 49, is it? 409, and then this one is the 2093.8. Okay, so you can compare with your answer in what we have solved this morning. Actually they are same, almost similar. Okay, so then once we have it according to our solution, we usually will go to step 2. So at the step 2, what we try to get is we will obtain the characteristic equation from A new. Okay, the A new for the step feedback, we have done the derivation, right? So just now we already have it. So if you can see that MATLAB very easy. Now we only have to use the command using the let's say the command we want is kp. Okay, we only need to use Ackerman's what is that, the command. So from here I just put the AP BP, CP, and DP. Okay, so with my pools, sorry, we just need the, I should let you see this one first. Okay, you may learn what is the acre. You can document, get the help file. So you can see that acre is a pool placement gain selection using the Ackermann's formula. So K will be equals to the acre A, B, and then the P. So what is that? What is A? What is B? Is the matrix A, matrix B. Okay, and then the P is your pools. So from here we will get this. Try to run. So you will see now you will have 3 gains based on the pools that you have designed just now. Okay, so so from here we already get the value of the gain. You can compare your calculation. They are most similar. Okay, so then it's not finished yet. I'll still would like to show you how can we form. Okay, we form the compensated state feedback model. Okay, so how to model it? Then you can use the AP new. Okay, equals to AP minus, we know, right, is a AP is a new, right? AP new is A minus BK, so BP multiply with our KP. So this is our AP new. So BP new will be the same with BP, and CP new will be the same with our CP, and same to the DP new will same to the DP. Okay, so from here you also can form. Okay, you can form the transfer functions of state feedback model. Then from here you can do in this way, which is numerator T, because just now we used the G already, and then numerator T. So remember just now we use is the transfer function to state space, right? So now you can use state space to transfer function command. So what you have to write here is AP new, BP new, CP new, and the DP new. Okay, so then from here the transfer functions, of course is a compensated one, so you can write T and T. So then you will see what is that. So let's run this first. Okay, you can see this is our AP new with the compensated your system. So now if you try to make them in the transfer function, so this is your closed loop transfer function with the step feedback controller. That's all. Thank you.